Hello, all third semester students. A very good afternoon to you all, and welcome to Enlightened Educators. So, today we are going to discuss with respect to the source transformation concept in detail, right? Source transformation concept we are going to discuss. So, just a minute. Yes, so in today's session, we are going to learn with respect to the topic that is source transformation, and this is the second session on network analysis crash courses, right? So, network analysis crash courses actually, just a minute, I'm very sorry for the distraction. Yes, in network analysis crash courses, actually, what is that we are going to learn is that we are going to learn with respect to the concepts in detail, that is, with respect to that particular concept in detail and how to solve that particular concept, like whatever the problems that is being given in the particular concept, how to solve that. And we are also going to learn with respect to the problems on that particular topic, and we are also going to learn the tips and tricks, and we are going to what I can say, tips and tricks with respect to those particular problem, right? So now let us see what is source transformation. Source transformation is nothing but we are going to convert, just a minute, I'm so sorry for the distraction. Yeah, we are going to convert what? You are going to convert voltage to current and current to voltage. What is this voltage to current? Is that if you have any voltage, what I can say, any voltage in series with the resistance, so what you have to do, you have to find out the current. If you want to find out the current, what you do, you will do I is equal to V by R, is it not? So that is what is the voltage to current conversion. So you get it as, that is your, what I can say, the I in parallel to the resistance, right? Then what is the current to voltage conversion? The current to voltage conversion is nothing but if you have this one, that is if you have any current in parallel with the resistance, so what is that you do, you do is that you are going to convert it into voltage, means you have to use the formula V is equal to IR. So this is what a source transformation, students. A source transformation is nothing but conversion of voltage into current and conversion of the current into the voltage. If you want to convert this voltage into current, what you have to do? You have to take a formula, say is equal to V by R, and if you want to convert the current into the voltage, you have to use the formula, say V is equal to IR. So this is what is the first thing that you have to see, right? Okay, so this is what is your source transformation. Okay, so just a minute, I'm very sorry for the distraction. Okay, so yes students, so please wait, I'm very sorry. So sorry for the distraction in the middle. I'm very sorry for this. Okay, yeah. So second thing what you have to know with respect to the source transformation is that how to solve the problems on source transformation. You learned what is source transformation, and how to solve the problems on source transformation you have to learn. Sorry. So before that you need to learn one more concept, say source shifting. You have to learn one more concept, say what? One more concept, say source shifting. Why you have to learn on source shifting is because, why you have to learn it is because you will get a clubbed problem. Say you will get a problem on mixture of source transformation and source shifting. They'll ask you to find out by using the by using the source transformation and the source shifting. So find out the voltage across or current across or what is the problem that is given, they'll ask you to find out, right? They'll ask you the club of source transformation and I'm sorry, and source shifting. So what is that you're supposed to do? What is source shifting? The very first thing with respect to source shifting is that, so if you have a two resistances present in parallel, or if you can consider one resistance and one inductance in parallel, and if you have what I can say, the voltage present over here, the voltage present over here, here it is resistance and here it is inductance, right? So for that, what is that going to happen is that, so your voltage, as you can see that the one end of the resistance and one end of the inductance is being connected to the one part, that is positive part of this voltage, right? Here you have to observe properly. Here you can see that, so the one end of the resistance, this end of the resistance and this end of the inductance is connected to the positive of the voltage, right? So in this case, what is that going to happen is that, in this case, what is that going to happen is that you are going to get a resistance, what I can say, in series with the voltage, and you are going to get an inductance in series with the voltage, right? So this is what has happened when this case, what I can say, comes into, this is inductance, right? I have written it as inductance I, okay? This stands for inductance, okay? So this stands for what? So this stands for what? It stands for inductance. So here I'll write it as I, and here I'll write it as what I can say the V. So this is what I can say the very first condition with respect to what? It is with respect to the source shifting, right? Now if I consider the second case, now if I consider the second case, what is that going to happen is that, so if you have, I'm sorry, please wait for a minute. I'm very sorry for the distraction. Yeah. Okay. So now here if you can see that there is a current over here and there is a current over here, and what I can say, that is I, and that current is then what I can say connected like this, right? This is my resistance R1 and my resistance R2. So as you can see now here that the one end of the resistance is connected to positive of the current and other end of the resistance is connected to the negative of the current. So what is that going to happen? The arrow mark is positive and the line is negative. So see, this arrow mark is positive and the line is negative. So if that is the case, so what is that going to happen is that, so you will get the resultant as say, that is R1 and the current I, and R2 and the current I, right? I hope you are getting my point, right? ನೀವು ಏನು ತಲೆನಲ್ಲಿ ಇಟ್ಕೋಬೇಕು, when you have to start solving this particular source shifting ಅಂದರೆ, if you have any voltage, if you have any voltage in your question, you need to see that the ends of the two elements, that is either the resistance or either the inductance, the ends of the two elements have to be connected to only one of the terminal of the voltages. What? The ends of the two terminal, the ends of the two terminals have to be connected to, sorry, ends in the sense there is only one end, right? One end of the two terminals, right? Sorry, one end of the two, not terminal, it is one end of the two, what I can say, the elements, right? Elements, okay, I'm sorry. Elements has to be have to be connected to, it is one end of the two elements have to be connected to what? It has to be connected to the, what I can say, the one terminal of the voltage, one of the terminal of the voltage, right? That means, as you can see here, this end of the resistance, this is positive or negative terminal, we don't know, right? One end, that is positive end or negative end, we don't know. It is according to the what I can say, whatever the resistance you have. But I have told you that resistance does not have any polarity, right? So this one end, that is either positive or negative end, this end and this end here is connected to only the positive terminal of this voltage. That is what is the case for your voltage, right? That is the case for a voltage. If you see for the current, what is that going to happen is that the what I can say, the ends of the two terminals are connected to the positive and negative of the current. See here, this end is connected to positive and this end is connected to negative. But here what is that going to happen? The two ends are connected to only one terminal, right? This end is connected to the same positive terminal of the voltage and this end is connected to the same positive terminal of the voltage. But here the two ends are connected to different terminals of the current. See, this end is connected to the positive terminal, which is 0, and this end is connected to what I can say, the negative terminal, right? They are not connected to the same terminal, but here these two ends are connected to the same old terminal, that is positive. So that is why these two have a very much difference, and please do make sure that you follow this particular without fail. This is what I can say, the source terminal, what I can, sorry, source shifting concept. This is what is the source shifting concept, right? So now let us learn how to solve what I can say, the source transformation problems. There are some techniques to solve the source transformation problem. So what are those techniques to solve the source transformation problem? I am going to explain it to you, right? Okay. And here there is one small change. I'm very sorry for the distraction. I'm very sorry. Here it is in parallel. Okay. Yeah, here it is in parallel. I'm so sorry for the distraction. If I have missed anything, I'm very sorry for the distraction. Here it is in parallel. Okay. Yeah. Okay, so this is in parallel. Don't consider what I told it before. I'm very sorry. This is in parallel, and this two is in what I can say, the series. This two in what I can say, the series, right? Okay, so now let me start with what I can say, the source transformation techniques, right? You have to remember. See here, if there is any if there is a connection like this, if there is a connection like this voltage will be in series with resistance and inductance, as you can see over here. And if there is any connection like this, so this what I can say, the I will be what I can say, the in parallel with these two resistances. Okay, yeah. So now if you consider with respect to the tips and tricks for solving the source transformation problems. So the very first tips and tricks is, what is the very first tips and tricks? So the very first tips and tricks is that it is the ideal voltage sources in series. So what did we learn till now? We learned till now with respect to what? We learned till now with respect to the water source transformation and water source shifting, right? And when we learned water source shifting, we have also learned how to solve it, right? So this is the methodology how to solve it. I told that also here along with water source shifting, right? Okay. Yeah. So here ideal voltage sources in series, right? So now what is that going to happen is that if you have any voltage sources in series, right? If you have any voltage sources in series, if you have V1 and V2, say, what is that going to happen is the total voltage will be what I can say, the V, that is equal to V1 plus V2. Okay, V1 plus V2. And if you, what I can say, have the different polarities, say if you have the different polarities, what is that going to happen is that it depends upon the polarity. So it depends upon the polarity whether you have to add or subtract, and then what is that going to happen, and when you write the total V, you are supposed to make sure that you are going to write whichever the voltage is the highest. If say V1 is equal to 10 and if say V2 is equal to 15, so then which is the highest? This is the highest. You are going to write the total voltage by writing the highest voltage polarity. I hope you got my point. Yes. Okay. And this we are going to discuss with respect to two of the problems in detail. So two or three problems we are going to take up live today in the evening so that we can finish off the source transformation topic today itself. Okay, in the crash courses. Fine. Okay. Now the second thing is that it has practical voltage sources in series. Practical voltage sources in series. So what is that going to happen now is that you have an voltage and here also have an voltage and a resistance. This is R2 and R1. This is V1 and V2. So then what is that going to happen is you can add the two voltages and you can add the two resistances. You need not to go to any of the simplification. Directly add these two voltages, you get V here, and directly add the two resistances which is R, that is R1 plus R2. Fine. Okay. So now let us come to the ideal, what I can say, the ideal, that is the current sources in parallel. What I can say, it is the ideal, what I can say, the current sources in parallel. So when you have an ideal current sources in parallel, so what is that going to happen is that you have two currents in parallel, that is I1 and I2. So then what is that going to happen? You have the terminals A and B. And what is that going to happen is that, so you can add these currents which are in parallel, right? So when you add these currents which are in parallel, you get the total I, so which is equal to the I1 plus I2, right? And here also, if the what I can say, the this one, that is the polarities are different. Say if it is, say, like for example, this is I1 and this is your I2, so it goes according to the polarity, and whichever is having the highest polarity, which current is the highest, that polarity is taken into consideration, as I told you in the same case as per the voltage, right? Then voltage I have told you that if the polarities are different, it goes according to the polarity whether you have to add or subtract, and which is having the highest polarity, you are going to, what I can say, right, that polarity. Like 15 is having the, like, voltage V2 is 15, which is very highest, so highest voltage polarity we are taking. In the same case for the currents also it happens to takes place. Okay, yeah. So now it is ideal practical current sources and parallel. Practical current sources and parallel. Okay, so now if you can see that you have the current I1 and you have, what I can say, the resistance R1, and you have, what I can say, the current I2, and you have, what I can say, the resistance R2, right? You have, what I can say, the resistance R2. So now what is that going to happen is that Now you can see that you can add the two currents I1 and I2, right? You can add the two currents I1 and I2. So therefore you get it as I is equal to, what I can say, the I1 plus I2, and your R is equal to R1 plus R2. So then you get it as the current I and the resistance R, right? Okay. So now in the next case, what is that going to happen? So in the next case is what is that going to happen? R is equal to, this is in parallel, right? I'm very sorry, I forgot to tell you. R, this is in parallel, right? So therefore what is that going to happen? What is when you have two resistances in parallel? It is R1 R2 divided by R1 plus R2, right? It is R1 R2 divided by R1 plus R2. If I miss anything, I'll just remember then and there itself and tell it to you. Right? I'm so sorry for telling it like this. It is two resistances in parallel. So therefore it is R is equal to R1 R2 divided by R1 plus R2. Fine? Okay. So very sorry if I'm missing anything. I'll just tell you then and there itself. Don't worry. Okay, na? Yeah. And this is the crash course session which I'm coming live every day and teaching it to you. So please do make sure that you just follow us for more and more updates on crash courses so that you will get to know what and all you are learning in the crash courses, right? So now what and all I'm teaching you, please do make sure that you learn this so that you can solve any problem without fail. Okay? Yeah. And now the next thing is that. So what is the next thing? So your next thing is what I can say, the practical voltage sources in parallel, or I can say PVS stands for practical voltage sources in parallel. So what is practical voltage parallel, you know, right? This is parallel symbol. This is parallel symbol, right? Okay. So what is practical voltage sources in parallel in the sense? So I have told you that there is an voltage and a resistance, right? This is what is called as practical voltage sources. Fine. This is what is called as practical voltage sources, and this practical voltage source will be in parallel with the other practical voltage source like this. That is V2 and R2. So now what is that going to happen? In this particular case, you have to make use of I is equal to V by R. So this one will get converted to I1 R1 and this will get converted to I2 and R2. So let me do that. So I'm going to get it as I1 R1 and I'm going to get it as what I can say, the I2 R2. I1 R1 and I2 R2, I'm getting it as. So now this is what? This is nothing but your practical current sources in parallel. You have got the practical current sources, what I can say, in parallel. So what is that going to happen? You going to get the resultant as, that is I and R, which is nothing but I is equal to I1 plus I2, and here R is equal to, that is what I can say here, R1 R2 divided by R1 plus R2, right? Okay. So now we got to know what is practical voltage source in parallel, right? We also learned what is practical voltage sources in series. As you can see here, we have learned practical voltage sources in series. Now we'll learn the practical voltage sources in parallel, right? Now we have also discussed with respect to practical voltage sources in parallel. Now let us discuss with respect to the practical voltage sources in series. Sorry, practical current sources in series. We learned practical current sources in parallel. Now we are going to learn the practical current sources in series. Fine. Shall we see that? Okay. So we'll see practical, PCS stands for practical current sources and series. So it is I and R, that is I1 and R1, terminal A. Now what is that going to happen is that here there is a current in parallel with the resistance, which I can tell it as V is equal to IR, right? V is equal to IR alva. So then what I'm going to get? So I'm going to get it as, that is your voltage in series with the resistance, and voltage in series with the resistance, wherein I got, that is what I can say, the practical voltage sources in series I got. And if I simplify this, I'm going to get it as V and R, wherein it is V is equal to V1 plus V2, R is equal to R1 plus R2, right? And one more thing we need to know. We got to know that ideal voltage sources in series is, if you have two voltage sources V1 and V2, then you will get it as V is equal to V1 plus V2 unta. So if you consider there are two voltage sources in parallel, say you have V1 and V2, right? Okay. So what is that going to happen? It is a ruled out case because there is no two voltages in parallel. And if you consider two current sources in series, if you consider the two current sources in series, so then I'm sorry for the distraction. Huh. Two current sources in series, so then what is that going to happen? That is also ruled out because you don't have any, what I can say, the current in series, right? And one more tip you have to remember, or one more thing you have to remember is that, so that is the tips and tricks. Let us see. So tips and tricks, I've told you, the very first tips and tricks is nothing but, if you have the voltage or current of different polarity, say if you have the voltage or current with voltage or current in different polarities, that is here we have discussed, this is one tips and tricks. If you have voltages and different polarities, so I told you that you have to do addition or subtraction according to the polarities, and then you have to take up the voltage, highest voltage polarity. If 15 is the highest voltage, take that voltage polarity. And even for the current, I told you the same, wherein if you have two currents of different polarities, you have to check with whether to add or subtract according to the polarities, and then you need to consider with respect to the highest current polarity. If I consider this as 10 and if I consider this as 8, this is a 10 ampere, which is my highest current. So therefore I take the polarity of this particular current and write it as, what I can say, I, right? So these are the two tips and tricks I have told you. Don't forget these tips and tricks. If you forget these tips and tricks, you will lose the marks in your exams, or your whole, what I can say, the whole problem will be zero. How the whole problem will be zero, because you will miss it here itself, right? If you get two voltages to add, or if you get two currents to add, what is that going to happen? You have to see the polarity first. You have to see the polarity, then add or subtract according to the polarity, and then take the highest current polarity or highest voltage polarity. If both the polarities are same, then you can take the same polarity. It is not that like you need to take this current polarity or this current polarity, because both the current polarities are the same, right? Okay. And the second tip and trick is that, if you have, just a minute, if you have, what I can say, volt resistance and series with the current, or what I can say, very sorry, now it's clear, or what I can say, the voltage in parallel with the resistance, these two are ruled out, because there should be no voltage in parallel with the resistance, or there should be no current in series with the resistance. I hope you're getting my point. These are the two tips and tricks that you have to follow. And with respect to the source shifting, you need to know that two elements. So two elements end, right? Ends of the two element, one end of the two elements. That is, for your first case, one end of the two elements are connected to only one terminal of the voltage, that is positive or negative terminal it will be connected to. That is one end of the two elements. If you have two elements, say resistance and inductance, as you can see over here, if you have two elements, say resistance and inductance, you have to see that the ends of the resistance, this end of the resistance, this end of the inductance are connected to only one end, that is positive end of the voltage. Right here, if you can see with respect to the current, the ends of the elements, that is the two resistances are the two elements, and the ends of the resistance are connected to the positive as well as the negative end of the current. Right, this is what is the structure. You have to see the structure properly. Structure ಹೇಗಿರಬೇಕು, ಒಂದು ವೋಲ್ಟೇಜ್ ಇರಬೇಕು. For that voltage, your two ends of the two elements has to be connected to only one terminal of that voltage, and you have to see in the figure that there should be a current ಇರಬೇಕು. ಆ ಕರೆಂಟ್ಗೆ ಏನಾಗಿರಬೇಕು, ಪಾಸಿಟಿವ್ ಎಂಡಿಗೆ ಒಂದು ಎಲಿಮೆಂಟ್ ಎಂಡ್ ಕನೆಕ್ಟ್ ಆಗಿರಬೇಕು, ನೆಗೆಟಿವ್ ಎಂಡ್ಗೆ ಇನ್ನೊಂದು ಎಲಿಮೆಂಟ್ ಎಂಡ್ ಕನೆಕ್ಟ್ ಆಗಿರಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ಇಸ್ ದ ಥಿಂಗ್, right? And if you get a structure like this is the simplified diagram. And if you get a structure like this is the simplified diagram. Don't take this into consideration because there is no current in series with the resistance. I am so sorry for telling it wrong. Okay, yeah. Okay, yeah. So that is why I just checked it once before continuing, right? There is any glitch in middle, I'll just check with that before continuing. So please do make sure that don't think me wrong. Okay, yeah. So now we learned all these things, and now let us see how the problems are coming. In general, the problems are coming in your exam. Say, convert the figure into one voltage source in series with the resistance or current in parallel with the resistance. Right? Okay. Right, this is the first question that they can ask for an exam, or they have asked for an exam. I'll tell you they have asked for an exam because they'll ask you convert the figure. So I'll read that question. Please wait. I'm sorry, I'm having my laptop over here. Okay, so okay. So the question is set to be as follows. Say that does reduce the network to a single voltage source in series with the resistance between the terminals C and B. ತರ question ಕೇಳ್ತಾರೆ, or they'll ask you to find the voltage or current across. Voltage or current across, that is what I can say, the 6 ohm, 5 ohm or any, right? Okay, any resistance. Okay, and then they'll ask you to find the, I'm sorry, now it is proper, find the V in the given figure. V means V will be present at any of the resistance, students. Here you have a resistance R. Here there might be V, and they'll ask you to find a voltage across V at this resistance. Anta. So for these things, what is that going to happen is that for the very first one, you can simplify all the elements that is given in the question. Say if you are given with the voltage, current, resistances, you can simplify. For this particular, what is that going to happen is that they'll specify a set of resistances. So that resistances you are going to keep it without fail. That resistance cannot be modified. What? If they have given the set of resistances like this, they have to find the current across 6 ohm or find the current across 5 ohm. What is that going to happen is that you have to keep that resistance as it is. You need not to. What? you need not to, what I can say, what? You need not to modify that particular resistance. You have to keep that resistance till the end, and at the end, whatever the modification you need, you can do it, right? And in this particular, what is the tips and tricks? The same thing. So we will be given at any resistance point. So what is that going to happen is that you can't even, what I can say, what? You can't even modify this. You have to keep this as it is till the end, and at the end you're going to modify. Okay, so now let us see what are the questions that has been asked to you all in general, right? So in general, here you can see with respect to the first paper, okay, with respect to the first paper, here you can see that. So see, this is what is the first question. Using source transformation and source shifting, find the voltage across 2 ohm resistor in the figure. See, here you can see that I'll make the figure bigger and I'll show you what is the tips and tricks for source shifting. Just a minute. Okay, so please wait. So now here you can see that if there is a current, so if there is a current, what is that going to happen here? So this end, what I can say, so here I'm very sorry for the distraction. If there is a current over here, so see, this 1 ohm, end of 1 ohm is connected to the positive, and this end of the 2 ohm is negative, end of the 2 ohm is connected to what? 2 ohm is connected to this negative, right? This 1 ohm end is connected to the positive of the 2 ampere, and this negative of the 2 ohm is connected to what? This negative of the 2 ampere. So this is how the voltage source is shifting. That is voltage source shifting in the sense I have told you that there is a, sorry, current source shifting, I'm sorry, current source is shifting. I'm very sorry for the distraction. Current source shifting wherein there is a current and a resistance like this. I've told you, right? So see here, I'm sorry. Yeah. See here. So this is what is that particular which I've already told you, and this is satisfying that. Okay. So here you can see that there is a voltage that is present over here and 2 ohm is present over here, and this you can't modify it. Okay, so this kind of problem I have already done that. So what I'll do is I'll just put a link on the description so that you can just check it out, and I'm going to do few of the problems in today's live classes, right? That means I'll take up that live class in the evening, right? So let me see this, what is the answer for this one. So here you can see that so see here you can see that. So this is what is the 1, right? So but here what is that going to happen is they have modified it, but they have kept the V as it is, right? They have modified but kept this V as it is. V is not eliminated. Okay, yeah. Now the second question paper, as you can see, the second question paper here you can see this problem I'm going to do it in the today's live class that is happening to takes place in the evening, right? See here, see the question. Just reduce the network shown in the figure. Question number 1A to the single voltage source in series with the resistance between the terminals A and B. This is what I told you. They'll ask you a question. This will be, we are doing it, okay, in the live class. That is the second live class for source transformation and shifting, right? Okay. And now here you can see that. So the next question that I've asked you is nothing but determine the voltage V using source shifting. So determine the voltage V using source shift and source transformation techniques only. So this is what is one question which I have already discussed in the this particular paper, and the same question is this. Okay, yeah. So now what is that going to happen is that I'll just go back. And the next question is, see, determine the current through 12 ohm resistor shown in the figure, question number A, using source transformation. This question is also done. I'll just put the link for this question. Okay, so these are the types of questions they've asked you, and all the questions are being discussed in my normal classes. If you want to watch that, you can watch it. So why need of this crash courses? Because I'm going to teach you all the tips and tricks. I'm going to teach you the whole concept in within one session in detail. so that if you see this crash courses, if you see whatever I tell you, if you understand whatever I tell you, you can solve whatever the problem that is given to you. It is up to you, your analyzation methodology. How do you analyze the problem and how do you write it? It is up to you. But what is that going to happen is, if you listen to this session and the unique session, you can easily solve whatever the problem given with respect to the source transformation and source shifting. Okay, so the next question is the same one, students. See, the next question is also the same one. So therefore, let us not see through that, but let me see what is the question given there. And here you can see that find the voltage across 2 ohm resistor. So by using the source transformation and source shifting, right? Source transformation and source shifting. Here the problem is somewhat different. So you can see that, yeah. So the same problem. So the same problem, students, here. Okay, so this problem is already done, and please do make sure that if you want this problem, I'm going to put the link in the description box below. I told you on the crash course we are going to do only 1 or 2 problems, which is very much important. All the other problems are done in the normal session, so please do make sure that you just check it out without fail. Okay, if you watch one videos of crash course, you'll understand what is the whole concept and you can attempt your exam in a easiest manner, right? And see, here you can see that this is also one problem wherein he's asked you to find a current through the 5 ohm resistor for the circuit shown in the figure, question number A. So this is what is the circuit. So what is that going to happen is, you just have to solve according to the question. So let us see this question, answer for this question. Okay, yes. So see, here you can see that. So this is what is the answer for the particular question. And here what they have done is that they have got this 20 and 30, right? This 20 and 30 they have got. So what is that going to happen is that here they have, what I can say, written 20 and 30 in parallel. How it was? It was 20 like this. This was 20 and this was 30, I hope so. So this two they have written in terms of like this. And now what they have got, actually, to be frank, now what they have got is that, so they have got two resistances in parallel, so that if you convert you get 12. And after that, now how we have got is that you have got one resistance in parallel with the current, that if you convert, that is you have got the practical current sources in parallel. So you have got that. So now we have to convert it into practical voltage sources in series, that we have done it over here. And after that you have got two practical voltage sources in, what I can say, the series, right? Two practical voltage sources. Practical voltage sources is nothing but there is an voltage in series with the resistance. So this is voltage in series with the resistance, which I call practical voltage sources, and the same thing is present over here, wherein you can say the two practical voltage sources are in series, right? Okay, two practical voltage sources are in series. And now we can see that if you solve this, you're going to get it as this resultant. You can directly take it as, that is what I can say, the V is equal to IR concept, right? Yeah. So V is equal to V1 plus V2. That is what I can say. The R is equal to R1 plus R2. You can take that, right? Okay. So now let me come to the next one. So this problem also I have done it, students. I'll just share this problem. Share this, what I can say, the problem video in the description link, right? This is also done. So find the value of Vx. So this I have done it in detail. So I'll just share this video link. So please to make sure that you follow it. ಇಲ್ಲಿ ಎಲ್ಲಾನು ಮಾಡ್ತಲ್ಲ, ನೆನಪಿನಲ್ಲಿ ಇಟ್ಕೊಳ್ಳಿ. ಒಂದೇ ಪ್ರಾಬ್ಲಮ್ ಮಾತ್ರ ಮಾಡ್ತಾ ಇದೀವಿ. ನಾವು ಮೇನಾಗಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇರೋವಂಥದ್ದು, ನಾವು ಏನು ಕಾನ್ಸೆಪ್ಟ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅದಂದರೆ ಏನು, ಮತ್ತು ಆ ಕಾನ್ಸೆಪ್ಟ್ಗೆ ಸಂಬಂಧಪಟ್ಟ ಪ್ರಾಬ್ಲಮ್ಸ್ನ ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡಬೇಕು, ಮತ್ತೆ ಕಾನ್ಸೆಪ್ಟ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂತೆ ವಾಟ್ ಆರ್ ದ ಕ್ವಶನ್ಸ್ ದಟ್ ಯು ಆರ್ ಗೆಟಿಂಗ್ ಫಾರ್ ಯರ್ ಎಕ್ಸಾಮ್ಸ್. And the next thing is, so how to solve those particular questions if you get that type of questions for exam. We are going to discuss only this much. If needed, we are going to do 1 or 2 problems, because I have done many in the normal session. If needed, I'll do it, okay, in this session also, right? And the next question that we have got it over here is the same. That is what I can say, this one, right? So determine the voltage across the current source in the figure. So this particular also we are going to do in the today's session, right? Which problem we are doing? This one and this one we are doing in the today's session. Okay, yeah. So it is voltage across the current source. So ee tara questions keltare, nimge idea bantalva? Okay. And so the next one is nothing but, so see here you can see that, so calculate the voltage across the 6 ohm resistor in the network as shown in the figure, right? This is also one problem that they have given to you. So here is the voltage. You have to find a voltage across this, what I can say, the 6 ohm resistor using source shifting technique. So source shifting technique andre you can see that here is a voltage. For voltage, what is that going to happen? You need to make sure for voltage that there is this 3 ohm end is connected to the positive of this voltage, and this 4 ohm end is connected to the positive of this voltage. I'll still make it bigger. Okay. So yeah. So here you can see that the 3 ohm, the end of the 3 ohm is connected to this positive here. This end of the 3 ohm is connected to this positive, and end of the 4 ohm is connected to this positive. So therefore here you have to shift this 8 into 3 and 4 respectively. So we'll see what is the answer for this problem. That is question number 1b. See here. Did you see? So I told you, right, 18 volt is shifted to 4 and 3. See here. This is for 4 and this is for 3. Right, after that you are going to simplify according to the question, right? You have to write like this. So ee tara bariyakinta you can write it like this. See, 18 volt is connected to 3 and 18 volt is connected to 4, right? So I told you that you have to keep it like this itself. You need not to change it. For some problem you have to change it, but for some problems you need not to change it. See, this 6 ohm is kept as it is. Then they have not done any modification. Okay, yeah. And now here you can see that this can be converted to current and parallel with the resistance. That has been done over here, right? That has been done over here, and they have simplified this particular, right? They have simplified this particular. That means they have taken 4 and 2 in parallel, I guess. So you get 1.33, and this is 1 ohm which is present over here, and this 6 ohm is present like this. They have kept the 6 ohm as it is, no changes till the end. It has been kept as it is. And now coming on to over here, you can see that this is what I can say, once again you have got this one, that is 4.5 ampere in parallel with 1.33 in series like this. That is, you get 5.9858. This is 1.33, and once again now we can see that you can take this 1.33 plus 1 is 2.33, and if you write the circuit like this, you get it as, that is what I can say, this whole thing. I'll take another color. I'm sorry. Yeah. So you can see that this whole thing constitutes the practical voltage sources in parallel, right? So it is, you can see that the practical, what I can say, the voltage sources in parallel. See, this is practical voltage source, means there is an voltage source in series with the resistance, and this is also an voltage source in series with the resistance, and these two are in parallel to each other. That is what we discussed over here, right? This is the practical voltage sources in parallel, right? Okay, so for this, what is that going to happen is that you have to simplify this by using this procedure. They have used the nodal analysis. You can use whatever methodology you require. Like say for example, I told you how we simplified the practical voltage sources in parallel like this. So you can do this methodology. This methodology is the easiest one, students. Don't go to nodal analysis and all. Okay, do this process only, whatever I have taught you. So this one, if you simplify, you get it into this one, and once again you can use the methodology at the end, right? Okay, yeah. And this is what is the particular questions, and today we are going to discuss, I have told you in the evening, this particular question, and this, what I can say, this particular question, this one we are going to discuss, and this one we are going to discuss in the today's session. And I hope you understood. So ನಾನು ಹೇಳಿದಂತೆ ಇವಾಗ ಏನೇನು ಹೇಳಿದ್ದೀನಿ, that is ideal voltage sources in series, ideal current sources in parallel, practical voltage sources in, what I can say, the series, and practical current sources in series, and practical voltage sources in parallel, and ideal current sources in series, whatever I have told you. All this you have to remember. You have to remember the tips and tricks so that you can easily pass the ಸೋರ್ಸ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್ ಆ್ಯಂಡ್ ಸೋರ್ಸ್ ಶಿಫ್ಟಿಂಗ್ ಟೆಕ್ನಿಕ್ ಇಷ್ಟು ಗೊತ್ತಿದ್ರೆ ಸಾಕು, ಯು ಕ್ಯಾನ್ ಡೂ ಎನಿಥಿಂಗ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಆರ್ ಎನಿ ಪ್ರಾಬ್ಲಮ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಸೋರ್ಸ್ ಶಿಫ್ಟಿಂಗ್ ಆ್ಯಂಡ್ ಸೋರ್ಸ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್ ಅಂತ ಹೇಳ್ತಾ I'll just wind up this session, live session, and I'm going to come back with the live session on today 7 p.m. or 8 p.m. by teaching this problem and this problem anta ಹೇಳ್ತಾ, and please do follow this live session for more and more updates anta ಹೇಳ್ತಾ. Thank you.